Hey guys, welcome back to Math from My Desk. Today I will be proving the divergence of the harmonic series using the integral test. So the harmonic series is as follows. We have the summation from n equals 1 to infinity of 1 over n. And so this actually diverges. So 1 over the summation of n from n equals 1 to infinity of 1 over n is essentially 1. So 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, and this will keep going on for until, infinity. So it will never stop. And so the way we're going to go ahead and prove that this diverges is using the integral test. So for the integral test to apply first, let's set f of n is equal to 1 over n. And we would need three criteria in which f is positive, f is decreasing, and f is continuous. And this would have to be true for all the n's which we care about, and in this case this is n is greater than or equal to 1. So let's go ahead and see this. So is f going to be positive? The answer is yes, because we're going to have a positive number in the numerator, which is 1, and over, anything n is greater than or equal to 1 is always going to be positive. So positive over positive is just positive. And so this criteria checks out. Then f is decreasing. So to do that, we can show that using the first derivative of 1 over n. So if we take the derivative with respect to n of 1 over n, this is equal to the derivative with respect to n of n to the negative 1, which is equal to negative 1 n to the negative 2, which is just negative 1 over n squared, which this is true, this is indeed negative, so f is decreasing. And so second criteria checks out. And then f is continuous. Well, yes, for n is greater than or equal to 1, f will always be continuous. 1 over 1 is continuous, 1 over 2 is continuous, 1 over 3 is continuous, 1 over, these are defined, 1 over infinity is also defined as 0. And so therefore this actually does work out pretty nicely. So the only case in which this wouldn't work out, it would be 1 over 0, which, that is not an n which we care about, because remember, this is our interval here, and 0 is not within this interval. So the third criteria also checks out. So now we can finally use the integral test. So we have the limit, as let's say b approaches infinity, of the integral from 1 to b of 1 over n with respect to n. So let's go ahead and solve for this integral. So we would have the limit as b approaches infinity of the integral of 1 over n. The antiderivative is the natural log of the absolute value of n, we're evaluating this from 1 to b. So let's go ahead and apply fundamental theorem of calculus part 2. So we would have the limit as b approaches infinity of the natural log of infinity, absolute value of infinity, minus natural log of 1, which is the same thing as the limit as b approaches infinity of natural log of infinity is infinity, minus natural log of 1 is 0. So we have the limit as b approaches infinity of infinity, which is just infinity. And so therefore, I can justify this by saying by the integral test, the harmonic series, so the summation from n equals 1 to infinity of 1 over n diverges. So I hope you guys enjoyed this short proof.